Now let us solve another problem, and the same kind of problem for the wave equation. A tightly stretched string with two fixed endpoints at x equal to 0 and x equal to L. Okay, a string is stretched, and initially it is at a position given by y is equal to y naught sine cube pi x by L. Okay, and this is released from rest from the position when we need to find displacement. We know that the equation of vibrating string is dou square y by dou t square is equal to c square into dou square y by dou x square. Here we have the boundary conditions y of 0t equal to 0 and y of lt is equal to 0, since both ends are tightly attached. Also the initial condition is given from the problem itself, so y of x0 equal to y naught sine cube pi x by L. Also, since it is given that it is released from rest, initially there is no velocity, so we can say that initial velocity is equal to 0. Okay, now we have the general equation for one-dimensional wave is y of xt is equal to c1 cos px plus c2 sin px into c3 cos cpt plus c4 sin cpt. This is the one-dimensional wave equation. So we can start from here. So first of all we substitute boundary conditions, that is y of 0t equal to 0. So when you put this into equation, what happens? We get 0 equal to y of 0t is equal to c1 into cos 0, c2 into sin 0, 0. So c1 into c3 cos cpt plus c4 sin cpt. Okay, so only possibility is c1 equal to 0. Otherwise, if the quantity, this quantity becomes 0, this is always in the y of xt equation, so that becomes 0. So only possibility is c1 equal to 0. So substituting c1 equal to 0 in the previous equation, we get y of xt is equal to c2 sin px into c3 cos cpt plus c4 sin cpt. Okay, now we put the other condition, other boundary condition, y of lt equal to 0. So we put 0 equal to y of lt is equal to c2 sin p, instead of x we put l, sin pl into c3 cos cpt plus c4 sin cpt. This goes. Okay, here also we can, I suggest either c2 equal to 0 or sin pl equal to 0 or this all term equal to 0, but these two are not possible, since in the equation itself we have c1 is 0, if c2 is also 0, this equation becomes always 0. So only possibility is, also if c3 cos cpt plus c4 sin cpt, this quantity is 0, if this quantity equal to 0, then always this displacement equation y of xt becomes 0. So only we suggest to take is sin pl equal to 0, because sin pl has different wave creation capacity. So sin pl is equal to 0 implies pl is equal to n pi, p is equal to n pi by l. So what we can do is we can substitute this back to this particular equation and form the equation. Okay, now we apply p equal to n pi by l in this equation. Now the equation was y of xt is equal to c2 sin px into c3 cos cpt plus c4 sin cpt. So wherever you find p equal to p, you put p equal to n pi by l. Now this becomes y of xt is equal to c2 sin n pi by lx, c3 cos cn pi by lt, c4 sin cn pi by lt. So this is our updated equation. So we have to give next initial value to this equation. Okay, now we have to add next initial value, that is dou by dou t of y of x0, which is given as 0. So for that, first of all, let us find the derivative of this thing that we already received. So we have to find the derivative of this first. So that is, derivative is dou y by dou t is equal to c2 sin n pi by lx. We'll get cn pi by l in the both terms, so we take that outside. So finally what we get is c2 sin n pi by l cn pi by l into minus c3 sin cn pi by lt c4 cos cn pi by lt. I'll do this if you want to do if you have any doubt. So we are finding derivative of this thing. So c3 in this term there is no t, so we have put this like this way itself. Okay, now in this other term we have t, so we have to take cn pi by l into derivative of cos cn pi by lt, that is minus sin cn pi by lt plus cn pi by l into c4 cos cn pi by lt. Okay, so by taking this term outside we get this term. So what we have to do is this. Okay, for that we apply t equal to 0 in this. So dou by dou t of y of x0 equal to, so wherever you find t you put 0, c2 sin n pi by lx into cn pi by l into, so sin 0 0 plus c4 cos cn pi by lt. So this ultimately gives equal to c2 c4 cn pi by l into sin n pi by l x cos cn pi by lt. Here when you see we have this equation, the most recent equation is this. Okay, this one. So in this if you put c4 equal to 0, nothing happen. Okay, but if you put c2 equal to 0, what will happen? This whole term will become 0. So only possibility is c4 equal to 0. Okay, only possibility is c4 equal to 0. Okay, so we'll do next on next slide. So what we get is, when you put c4 equal to 0 in this equation, so we have to put c4 equal to 0 in this equation. Okay, we have to put, I will write again in the other slide. So we have to put c4 equal to 0 in this equation. So what we get is, new y of xt becomes c2 sin n pi by l x into c3 cos cn pi by l t. Okay, so this is c2 c3 sin n pi by lx cos cn pi by lt. Okay, this is our new y of xt. Okay, Now we have this term, so we can put c2 c3 as bn for the time being. Okay, so what we get is y of xt is equal to c2 c, this is equal to bn sine. Okay, so since bn is a constant and we have this many terms, that means b1 sine n pi by l x cos n pi by l ct, b2 b3 etc. So by using the principle of superposition we can take sigma, this as sigma bn sine n pi by l cos n pi by l ct. Okay, so by using principle of superposition we can take this whole term, we can sum and get the equation. So finally we get the equation or solution for one-dimensional wave equation. This is a general solution. Okay, now we'll go back to the question and see what we need to do. But we also given that y of x0 equal to the previous question, we can see that y of x0 equal to the initial position is equal to y naught sine cube pi x by l. Okay, we can take y naught sine cube pi x by l. Okay, so we can compare these two to find the coefficients, bn coefficients. Okay, for that let us compare these two. First of all, so when you compare these two, what we get is y naught sine cube pi x by l is equal to, so we put in this equation we put t is equal to 0. Okay, in this equation we put t equal to 0. So what we get is this term becomes 1, this term becomes 1. So what we get is y naught sine cube pi x by l, the initial position is equal to sigma bn sine pi x by l into 1. Okay, so we take sine cube pi x by l, we expand that sine cube theta is equal to 3 sine theta minus 4 sine 3 sine theta minus sine 3 theta divided by 4. Okay, so we take that and we compare this. So what we compare the coefficient, but that means sine pi x by l, here also sine pi x by l, sine 3 pi x by l, here also sine 3 x pi x by l. Other terms we expect that this is 0. Okay, so when comparing we get only the terms b1 and b3, other terms are 0. So finally what we get is sine y of xt is equal to the y b1 term and next is the b3 term, rest of all 0. Okay, this is the final solution.